asked to go and find the x values where tangent of x equals 2.5. And they give us a parameter. They said x has to be between 0 and 2 pi. Now there's an algebraic way to do this, and there's a graphical way to do this. So the algebraic way is simply to take the inverse of tangent and whatever you do on one side of the equation you have to do on the other. So by taking the inverse of both sides, remember inverse functions undo what the function does. It sounds funny, but they cancel each other out basically is what I'm trying to say. And so what you do is on the left hand side you're left with x, and on the right hand side you're left with tangent inverse or arctan of 2.5. Now we could do this in degrees, we could do this in radians. It really doesn't matter. I think the textbook wants us to do both. So what Mr. Adams is going to do here, slide this over a little bit and turn on my handy dandy calculator, clear the screen. And if I hit second tan, that pulls up the arctan. And then I enter in 2.5, and I really should have checked the mode. It's probably degrees, right? So the degrees are 68 degrees, roughly. We'll say 68.2 degrees. Now let me double check my book. Oh no, they want it in radians. Oh, you know why? Oh, let me tell you about that too. How do I know they want it in radians? Well, because the domain of x was given in a radian measure. If they want the answer in radians, you'll see pi. If they want the answer in degrees, you'll see like 0 to 360 degrees, right? Because 2 pi is 360 degrees, right? So now how do I get this answer in radians though? Yeah, we could do that, or we could just come in here and change our calculator to radian mode, right? So now let's do that again, but now we'll get a radian answer. So now in radians, this will be 1.19 radians. And we have to think about the period of pi, or not the period of pi, the period of tangent, because tangent is a trig function and it repeats itself. And so usually it's some variation of pi. You can either add pi or subtract pi or 2 pi. So let me show you what this looks like graphically though. So if I come in and I got to clear a bunch of stuff out here and I graph tangent. And I want to know when tangent is going to equal 2.5. And I graph the two of them. Oh, I got to turn off my stat plot. 4. And then zoom standard. What I'm looking for is the intersection of tangent. So tangent is this little thingy here, right? So let me sketch that a little bit for you guys. Okay, and what we're looking for is when it equals 2.5. So I'm going to move the calculator over here. And so what we're looking for are these two intersections because remember x is from 0 to 2 pi. So we're going to see how many answers we have between x equals 0 to 2 pi. So if I hit trace, we know that the first answer is 1.19. So if I enter in 1.19, and remember the calculator, we rounded the answer, but my y value should be pretty close to 2.5, okay? Now what I need to do is figure out maybe this next intersection right here. So what would you guys guess I could add to my 1.9 to get that answer? And where would you get that answer from? See, tangent has a period of pi. Remember that sine and cosine have a period of 2 pi, but for tangent it has a period, or it repeats itself at pi. And if we don't put anything that transforms the period inside the parentheses of tangent, then that period should remain pi. So now if I take 1.19 plus 1 period, which is pi, and then I hit enter, I just shift over from here to here. Now 2 pi is approximately 6.28. So is x equals 4.33? Is that within our parameters? In other words, does that fall, is this trapped between 0 and 2 pi?
No.
Yeah. So if I add pi to that one more time, will I be outside of the parameters?
Yeah.
Yeah. Okay, so I see some looks. Do you guys have any questions as to how I did that?
So, I think I kind of lost you on what you got. What's my big brain?
So here's, okay, so here's,
What are we looking for?
okay, so here's what we're looking for. When I say tangent of x equals 2.5,
Yeah.
that means if I look at the tangent function across its domain, when I plug in a certain value for x, I should get 2.5 for y. That's what this is saying. All right? But now here's the thing. When I pull up the calculator and you look at the calculator, how many times does that happen?
A lot.
A lot. Infinitely many times. Right? Because the domain of tangent is basically, well, it's almost all real numbers except for those vertical asymptotes at multiples of pi over 2. So how do I determine which solutions I want to use? Okay? Well, the textbook helps us out and says we're only going to focus on the solutions from 0 to 2 pi. So only x from 0 to 2 pi. Another way you could look at it is I could come in here, and if I set my boundaries for my viewing window for x equals 0, and then for my minimum, and then my x max as 2 pi, like that, and I graph that, we're just looking at these two solutions right here, this one and this one. But there's infinitely many times, okay? Now what your calculator does, your calculator only calculates one, and that's the 1.19. And the way that it calculates that is it just makes a basic right angle triangle, okay? So these are the two solutions. I mean, we're done with the problem. Let's do another one maybe, and that'll help solidify in your mind what we're trying to accomplish.
Just do 32.
Yeah, well, let me do one more thing though, just to kind of help you guys understand what's going on. If I come in here and I enter in tangent of 4.33, I'll get about 2.5. If I enter in tangent of 1.19, and remember we rounded these values, I'll get about 2.5. Does that make sense? So if I continue to add pi to this stuff on the inside, it'll always be like 2.49, 2.48. Okay? Now let me show you one more thing where that comes from, because it's important. Where that comes from is this is based on a standard circle, right? We're saying that if I come around 1.19 radians, right? Which is, I don't know, what would that be? Well, it's not that far. It's 68 degrees. I drew it kind of far. So it'd be right around here. This is 1.19 radians. I'm going to make a right triangle, okay, where the ratio between the, remember that tangent of theta is equal to the opposite over the adjacent. And so this proportion here really could be like 2.5 to 1 or something, however you want to write it out, right? Does that make sense? Now, that is a right angle triangle, but now if I go to 4.3 and I keep on going, I'll end up with the exact same triangle, but now my triangle will be here. Does that make sense? And the difference here is now I'm going to have a negative 2.5 and a negative 1. But what happens when you take negative 2.5 over negative 1? You get a positive 2.5. And that's where that comes from. And so what did we do? We added 1 whole pi to get to that other triangle.